A very important question of the trigonometry. If sine theta plus cos theta is equal to P and sec theta plus cosec theta is equal to Q, prove that Q into P square minus 1 is equal to 2P. We will start with the LHS, left hand side. Q into P square minus 1. In place of Q, we will put this expression sine sec theta plus cosec theta. In place of P, we will take sine theta plus cos theta. See, in place of Q, we took this one, and in place of P, we took here P is equal to this sine theta plus cos theta. It open this by identity a plus b whole square. And this minus 1. Now see, sine square plus cos square theta identity says that is 1. In place of sine square cos square theta, you can take the 1. This is as it is, and minus 1. Now this 1 minus 1 will be cancelled. For rest of the portion, I am writing here sec theta plus cosec theta. 1 cancel, we will write only 2 sin theta cos theta. Now we will multiply this one. See, cos and sec inverse to each other, they will cancel, and here sine and cosec are also inverse to each other, cancel. Now we will have 2 sin theta plus 2 cos theta. We can take the 2 common in the brackets, sin theta plus cos theta. You can see in the question sin theta plus cos theta is given P. So in place of sin theta plus cos theta, we can write 2 and this P. That was asked in the question. To prove this one, Q into P square minus 1 is equal to 2P. So RHS becomes 2P, hence proof. So you can see at a glance, we started with the LHS and we proved this RHS 2P.